Hello and welcome. In this video, we're going to be looking at a super important integration technique called integration by U substitution. I will show you how to solve using integration by U substitution. First of all, I want you to remember that if we have an integration of, let's say, x squared dx, this is super easy to integrate. We know the power rule says that this is going to equal to add 1 to the power and then over the new power. And then don't forget the constant of integration, since this is an indefinite integral. This is a super easy case to integrate. However, not all questions are this easy. Let's take a look at a question that looks like this. We have integration of 5x plus 4 all to the power of 5 with respect to x. So how can we integrate this question? So someone might tell me we could distribute the power, which is basically 5x plus 4 multiply itself 5 times, which is going to be like 5 brackets of and so on of 5x plus 4, and you will need to expand everything, and then you will have a bunch of terms. You will take each term and do the power rule for each term. It is doable. However, it's very demanding, and it's very risky to do errors in this. So another way, we can do something that is called U substitution integration. So from its name, we substitute some expression inside this question, and instead of this expression, we will write U. So U substitution goes like this. Let me try and say that 5x plus 4, I'm going to name it U, basically. So I'm going to say that U, I will substitute 5x plus 4 with U. So I will say that U equals 5x plus 4. Okay, and then I will also need to find du by dx. What's du by dx is basically differentiation of u. Okay, and I've done a differentiation series, which I will leave a link to it on the top right hand corner. Feel free to check it out. So differentiation of 5x plus 4 is nothing but 5. Okay, so over here I can do integration of, instead of 5x plus 4, it's going to be u, and 5x plus 4 is raised to the power of 5, so it's going to be u raised to the power of 5 dx. However, there is a problem here, is that I have one variable integration and I'm respecting to a different variable dx. So if there is a way where I can substitute this dx with a du, it will make my life so much easier. And this can be done from here. Because you might ask yourself, why did he get the differentiation? We only substituted. The differentiation of u will help us to replace dx in terms of du. And let's see how we will do that. So this, I can rewrite it as dx is going to equal, I'm going to move the dx over here, I'm going to divide by 5, so it's going to equal du over 5. So now I can replace this dx with du over 5. Now I just have integration 1 over 5. I'll just put this 1 over 5 up front, u power 5 du, and this is super simple. I can do it using the power rule. This is going to equal 1 over 5 u, add 1 to the power over the new power, and don't forget the constant of integration. And then after doing the integration, I can substitute, because at the end of the day I want my answer in terms of x, so I can substitute back the u into the x as follows. So this is going to equal 1 over 5 instead of u now. Okay, it's 1 over 5 times 1 over 6, so it's basically 1 over 30. Okay, instead of u to the power of 6, I'm just gonna replace it with 5x plus 4 to the power of 6 plus c, and this is how to perform U substitution and integrate using U substitution. We're going to take a look at lots of other examples to make sure you understand this and the various scenarios it can come with. So let's do this together. So let's say we have a question that says, please integrate square root of 4x minus 5 with respect to dx. So this also, I can write it as 4x minus 5 power half, because I know square root of something is the same as powering this thing by half. So what I can do is I can replace what's inside with u. Okay, so let's try that. So u equals 4x minus 5. Again, the next thing, I will get the differentiation of this expression. So du with respect to dx is basically differentiation of this. Differentiation of 4x is 4, differentiation of minus 5 is 0. And I know that I will need something in terms of dx, so right away I will put dx as the subject in this expression over here. So it's going to be dx equals du over 4. And now I can do my substitutions. So this, I can rewrite it as, instead of 4x minus 5, I will put in a u. This u is to the power of half. And instead of dx, I'm going to write du over 4. And now I can do my integration. This 1 over 4, I can put it in the front, inside or outside the integration, it doesn't matter. It's going to be integration of u power half du. So this is also very simple from the power rule. I know that I will need to add 1 to the power, so half plus 1 is basically 3 over 2, and then divide by the new power. So dividing 3 over 2 is the same as multiplying the reciprocal, multiplying 2 over 3. So I like to think of it as, if I want to divide by 3 over 2, is the same as multiplying 2 over 3. And then we obviously have a c, which is the constant of integration. So over here, this is going to equal 1 times 2 is 2, 4 times 3 is 12. So 12u to the power of 3 over 2 plus c. I can simplify this to divide by 2 up, divide by 2 down. So it's basically u power 3 over 2 over 6, because 2 divide 12, this 2 is gone, this is 6 plus c. So this is my answer. And again, I can switch back to my x, okay, using this over here. So u is 4x minus 5. So it's basically 4x minus 5 power 3 over 2 over 6 plus c, and this is the answer to this integration. So u substitution is nothing but making my integration easier, cleverly choosing a way to make my integration easier, and then after integrating, I'll bring it back to its original form. Okay, so let's say we have another question that looks like this: 3t squared multiply t cubed plus 4 to the power of 5 with respect to dt, and I need to integrate that. Again, I can use t cubed plus 4 as u, and I will teach you how to choose u. Do I choose it as 3t squared, or do I choose it as t cubed plus 4, or what do I choose? I will show you, and this is a perfect example to show you. Okay, if I choose u as t cubed plus 4, I know that my du by dt is going to equal 3t squared. Then I can say that dt, because at the end I want to replace this dt, so I'm going to make it the subject. Dt is going to equal to du over 3t squared. Let's substitute everything. So I have an integration of 3t squared multiplying, instead of t cubed plus 4, I'll put in u simply to the power of 5, and instead of dt, I'm going to put du over 3t squared. And here I'm going to find something super interesting. You might tell me, okay, I have a t here and I have a u. How can I have two variables and integrate? Yes, you're right, you cannot. But we can see that here, that 3t squared is going to cancel with this 3t squared, and we're going to end up with only integration of u power 5 with respect to du. This is going to equal to u power 6 over 6 plus c. And if I want to switch back, I will, instead of u, I will put t cubed plus 4 all over 6, and this is to the power of 6 plus c. So why did I choose u as t cubed plus 4? Right away when I saw the question, I saw that this t cubed is higher power than this t squared. And ultimately, as a rule of thumb, usually you will choose your u substitution, the expression with the highest power of the variable of t or of x or whatever. Okay, and then what you want is that you want your differentiation of your u to equal something that is already there multiplied to the question. Okay, so when these two things are there, this is how you know you chose your right u, because when the differentiation is equal to a t squared, and here I have a t squared, I know at the end I can cancel these two together, and I'm gonna show you in lots of other questions, so I make sure that you understand it fully. So let's take another example. Let's say we have integration of t squared times t cubed plus 4 all to the power of negative half with respect to dt. Okay, straight away I see two expressions. Okay, I know that this is t cubed, this is of a higher power than the t squared, so probably my u is going to be my t cubed plus 4. Okay, and now I know that when I get my du by dt, it's going to equal 3t squared. So in my differentiation, I have a 3t squared, I have a t squared, and in the question I have a t squared. So I know that they will cancel with each other, so this is a perfect substitution. So from here I can say that dt equals to du over 3t squared. Let's substitute everything. So I'll have my t squared. Instead of t cubed plus 4, I'm going to write in u power negative half. And instead of dt, I'm going to put in du over 3t squared. And again, I will see that this t squared is going to cancel with this t squared. And I'm going to be left with integration of, I have a 1 over 3 here. I will throw it in the front. I have a u power negative half with respect to u. This is now a normal integration where I can use my power rule. So this is going to equal to 1 over 3 u power negative half. Adding 1 to the power is going to be negative half plus 1 is going to be half, and then dividing by the new power. So dividing by half is the same as multiplying by 2 over 1, or simply multiplying by 2, and I never forget my integration constant. So the answer is going to be 2 over 3 u power half. Let's switch back our u into the t expression. So this is going to equal 2 over 3. Instead of u is going to be t cubed plus 4 all to the power of half plus c. And this is now my answer to this question. So let's take another example. Let's say we have an integration of cosine of 2x plus 1 with respect to dx. And in my previous video, I went through the integrations, okay, of special functions such as trig functions, exponential functions, and the function 1 over x. I'd highly recommend you go watching this video and leave its link on the top right hand corner. So we know that the integration of cosine x is equal to sine x plus c. Okay, so over here, if I did substitution where I say that u is going to equal 2x plus 1, I'll have du by dx as differentiation of 2x is 2, differentiation of 1 is 0, so dx I can write it as du over 2. And now I can substitute everything. So cosine of, instead of 2x plus 1 is going to be u, instead of dx is going to be du over 2. So this is going to equal integration of half cosine u du. So this is equal to half integration of cosine u is sine u plus c, and I can write this back. Instead of u, I'm going to write in 2x plus 1 to have it in terms of x. So it's going to be half sine of 2x plus 1 plus c. Okay, so this is also how to integrate using U substitution for this type of questions. Okay? So let's take another question. Let's say we have integration of sine to the power of 10 of x multiplying cosine of x with respect to dx. Sine x to the power of 10, I can write it as sine 10 to the power of x, sine to the power of 10 of x. These two are basically the same. This is just different ways that we write the sine or the trig functions with a higher power. So from here, I can see that this fits my original criteria. Why? I have something that is of a higher power of something else, and I know that this thing, sine of x, its differentiation is basically cosine of x. Okay, so if I chose u to be sine of x, my du by dx is going to equal cosine x, and now my dx is going to equal du over cosine x. And if I substitute everything, instead of sine of x is going to be u x to the power of 10 multiply cosine of x, okay, multiplying dx. What's dx? Dx is basically du over cosine of x, and I can see that here cleverly cosine and cosine will cancel out, and I will just have an integration of u to the power of 10 with respect to u. So this is basically equal to u add 1 to the power over the new power plus c. Now changing u back into sine x is going to be sine power 11 x over 11 plus c. Let's take another example. Let's say we have integration of sine of x over cosine of x to the power of 5. This is the same as doing the 5 over here, okay, but this time I want to put it here to show you that it's the same. So again, I have something to the to a higher power, okay, and I know that the differentiation of cosine x basically includes a sine x, right? So over here, if I chose my u as cosine of x, my du by dx is going to equal negative sine x. So my dx is going to equal du over negative sine x, or basically negative du over sine of x. And now if I want to substitute everything, I'll have sine of x over, instead of cosine x, I'm going to put in u to the power of 5. Instead of dx, I'm going to put in negative du over sine x. And then I will see that sine and sine will cancel. This is going to equal integration of negative 1 over u to the 5th power respect to du. This I can rewrite it as integration of negative u to the power of negative 5 respect to du, because I know if I have an a power m power negative m, this is equal to 1 over a power m. So when I have a power, multiplying this power by negative basically flips my fraction. What's up goes down, what's down goes up. So here it was a u power 5 down. If I want to put it up, I can. However, I will need to multiply by power by negative 1. So doing the power rule over here, this is going to be negative u minus 5 plus 1 is negative 4 over the new power, which is negative 4 plus c. Negative and negative cancel. I will have an answer of u to the power of negative 4 over 4 plus c. Switching back the u to cosine x, I will have cosine of x to the power of negative 4 over 4 plus c. Or I can rewrite this as 1 over 4 cosine to the power of 4x plus c. Alright, continuing, let's take another example. This example goes like this. Let's say we have an integration of root x minus 1 all to the power of 2 over root x. So again here I have this root x over here is powers of 2, so it's of a high power of the lower one. So basically probably my u is going to be my root x minus 1, because in U substitution you cannot get it right away. You need to try first. You need to try your u as square root of x minus 1 and see if it works. So let's do that. So if I did u as square root of x minus 1, my du by dx, okay, because this I can write it as x power half minus 1. So differentiated x power half minus 1 is basically half x power negative half, okay, or basically equal to 1 over 2x power half, or ultimately equal to 1 over 2 root x. So this is du by dx. If I want dx, I'm going to multiply this over here, this over there. So dx is going to equal 2 root x multiply du. So let's substitute everything. I'll have an integration of u squared over root x. Okay, this is with respect to dx. And dx is going to equal 2 root x multiply du. And I will see that root x and root x will cancel, and I will have a whole integration only in respect to u. This is my main goal. I want a new integration, a simpler one in terms of u, no other letter is there. So this is equal to integration of 2u squared du, which is equal to simply 2u adding 1 to the power over the new power plus c. Now substituting back u as root x minus 1, so it's going to be 2 over 3 times root x minus 1 to the power of 3 plus c, and this is my answer over here. Let's take another example. Let's say we have integration of x cubed e to the power of x power 4 respect to dx. Again, I can see that I have an expression x power 4, and I know that the differentiation of this expression is going to give me something in terms of x to the power of 3. So it's wise to try my u as x power 4 and see. So now du by dx is going to equal 4x cubed, and from here I can say that dx equals du over 4x cubed. Let's substitute everything. So I'm gonna have x cubed e, instead of x power 4 I'm just gonna have a u. Instead of dx I'm gonna put in du over 4x power 3, and again I can see that x power 3 will cancel out. I will have an integration. I'll put the 1 over 4 over here, e to the power of u du. So from the previous video, you know the integration of e to the power of anything is e to the power of that thing. So it's the same. So this is going to equal 1 over 4 e to the power of u plus c. Instead of u, I'm going to write e to the power of x power 4 plus c. And this is my answer over here. Right. Let's take another interesting question that you might face. We have square root of x square root of 3x plus 2. Okay, the expression here under the square root, okay, is 3x plus 2. X is a power of 1, x here is a power of 1. So basically I have something that's a little unusual. Usually, let's say this is 3x power 2, so when I differentiate this, I'm gonna have an x or blah blah blah, but here it's x power 1. So let's see how we do that. So let's say we take u as 3x plus 2. My du by dx is simply differentiation of this, which is 3. So my dx, this is obviously in respect to dx, my dx is equal to du over 3. So let's substitute everything. Have an x square root of 3x plus 2 is basically u, dx is du over 3. However, here I have a problem. I have a u and I have an x. Okay, not everything is in terms of u, and I don't know what to do with this x because it's not cancelled with anything. Here, what I can do is from here I can get an expression for x in terms of u. And from here I know that 3x will equal u minus 2 because I subtracted 2 from both sides, and then divide by 3, basically x will equal u minus 2 over 3. So this is my expression for x now. So I can replace this x with u minus 2 over 3. So this is going to be integration of u minus 2 over 3 times square root of u times du over 3. So over here, I have a 1 over 3 times a 1 over 3, that is 1 over 9. So integration of 1 over 9. And then this is multiplied to u minus 2. And this is multiplied to square root of u with respect to du, right? So over here, I can multiply this root u inside. So I'm going to have a 1 over 9 integration. Okay. U power 1 times u power half. I know that a power m multiply a power n is equal to a power m plus n. So power 1 times u power half is basically u power 1 plus half, or u power 3 over 2, which is 1.5. Minus, this is super easy, 2. And instead of writing root u, I'll just write u to the power of half. It's the same thing, du. So over here, if I want to expand, it's going to be integration of 1 over 9 u to the power 3 over 2 minus 2 over 9 u to the power of half, respect to du. And now it's integrationable. I can integrate it using the power rule. So this is going to equal 1 over 9 u. Adding 1 to 3 over 2 is going to make it 5 over 2. And then dividing by the new power. So divide 5 over 2 is the same as multiplying 2 over 5. And then I have a minus 2 over 9 u. Adding 1 to half is basically 3 over 2. Dividing by 3 over 2 is the same as multiplying 2 over 3. And I won't forget my integration constant. So this is going to be 1 times 2 is 2. 9 times 5 is 45. So it's going to be 2 over 45 u to the power of 5 over 2 minus 2 times 2 is 4. 9 times 3 is 27 u to the power of 3 over 2 plus c. So now I can substitute every single u with 3x plus 2. So let's do that. So this is going to be 2 over 45 multiply 3x plus 2 to the power of 5 over 2 minus 4 over 27 3x plus 2 to the power of 3 over 2 plus c. And this is my answer to this integration. Let's take one more example. So let's say we have a question that says integration of 6x square root of 5x plus 1. Again, this is of the similar type. We have power 1 over here, so probably we're going to have something similar to what we had. So let's say u is equal to 5x plus 1. That makes du by dx equals to simply 5, which makes dx equals to du over 5. This is with respect to dx. Okay, so let's substitute everything. I'll have integration of 6x square root of u. Instead of dx is going to be du over 5. Okay, and from here I can find an expression for x. I'm gonna subtract 1, divide 5, divide 5. So x is going to equal u minus 1 over 5. So I can rewrite this as integration of 6 multiplying u minus 1 over 5 multiplying root u over this 5, which is basically this 5, multiplying du. So now let's take all of these out. I'm going to have integration of 5 times 5 is 25, and I have a 6 on top, so it's 6 over 25 of u minus 1 times square root of u with respect to du. Again, I'm going to distribute, actually let me write this u square root of u as u power half. Okay, so I'm going to distribute it inside. I'm going to have an integration of 6 over 25 times 1 plus half is u to the power of 3 over 2 minus u to the power of half respect to du. Okay, so this is basically integration of 6 over 25 u to the power of 3 over 2 minus 6 over 25 u to the power of half du. Over here I can do my integration. It's going to be integration of, sorry, it's going to not integration, we are already integrating. So 6 over 25 u, 3 over 2 plus 1 is 5 over 2, divide 5 over 2 is the same as multiplying 2 over 5 minus 6 over 25 u, adding 1 to half is 3 over 2, dividing by the new power, dividing 3 over 2 is the same as 2 over 3, multiplying, and then I won't forget the plus c. So over here I will have 6 times 2, which is 12, over 25 times size, which is 125, u to the power of 5 over 2, minus 6 times 2 is 12, over 25 times 3 is 75, u to the power of 3 over 2, plus c. Over here, can I simplify this? No. So this is 12 over 125. Instead of u, I'm gonna put in 5x plus 1. So this is 5x plus 1 power 5 over 2 minus, can I simplify this? Yes, I can divide everything by 3. So it's going to be 4 over 75 divided by 3 is 25. 5x plus 1 power 3 over 2 plus c. And this is my answer to this question. I hope this video was helpful. I hope you gained information, or I made it a little easier for you to think about U substitution integration. Please don't forget to leave a like, comment down below if you have any questions. Also subscribe, which is super important. Check the other videos, and thank you so much for watching. Have a nice day.